Hey guys, Mr. Backerberg here. In this video, we're going to look at Gaussian elimination. So Gaussian elimination is the process that we're going to use to take a system of linear equations and transform it into row echelon form. And there's three operations that we can use to end up getting an equivalent system. The first operation is that we can interchange any two equations. So we're going to have a list of three equations and we can rearrange them in any order that we want them to be in. Number two says that we can multiply or divide an equation by a non-zero constant. And then number three says that we can add a multiple of one equation to another equation. So those are the three operations that we're going to use to take a system of equations and put it in row echelon form so that we can more easily solve the system. So in this example, we're going to look at using Gaussian elimination to take this system and put it in row echelon form so that we can solve this system. Now remember, row echelon form has that stair-step pattern to it where we're gradually getting rid of variables. Our top equation, we want to lead off with a plain x. Our second equation, we don't want to have any x's, and we want to lead off with a plain y. And then our last equation, we don't want to have any x's, we don't want to have any y's, and we want to lead off with a plain z. So as we're looking at this system, I'm going to work on building a new system that's hopefully in this row echelon form. So for our top row, we want an equation that leads off with a plain x. So as we're looking at this system that we've got right now, our top equation does not lead off with a plain x. It's got that 3 in front of it. But as we look at the second equation, this equation does lead off with a plain x. And one of our operations says that we can rearrange these in any order that we want. So instead of this equation being second, I'm going to move it up to the top of my system. And I'm going to start building my new system over here. So I'm going to move that x minus 2y plus z equals 7 up to the top of my new system. So we've used this middle equation, so I'm going to put a mark next to it to remind myself that I've already used it in my new system. Now I need to look at one of my other equations, and let's just work with this top equation. Let's work with this 3x minus 5y plus z equals 14. Now we're going to transform this into our second equation. So for our second equation, we're not allowed to have any x's in there, and we're supposed to lead off with a plain y. So the first thing I want to think about is using some kind of elimination to help me get rid of these 3 x's that are currently in the front of this equation. So in order to get rid of 3 x's, we need negative 3 x's. So I'm going to take this middle equation right here, and I'm going to multiply the entire equation by negative 3. Now it's really easy to make mistakes as we're going through and doing this Gaussian elimination, so make sure you're taking your time, make sure you're being careful with your negative signs. When we get to the addition part, make sure you're adding correctly. So just go through this process nice and slow. So the first thing I'm going to do is take that negative 3 times that x, and I get negative 3x. Then I take negative 3 times negative 2y, and I get positive 6y. I take negative 3 times z, and I get minus 3z. And then I take negative 3 times 7, and I get negative 21. Now we're going to add these equations together. The 3x and the negative 3x will cancel each other out. Negative 5y plus 6y is going to give me positive 1y. Z minus 3z is going to give me minus 2z. And then 14 minus 21 is going to give me negative 7. Now this equation leads off with a plain y, which is what we wanted out of our second equation. So I'm going to put this as the second equation in this new system that we're building over here. And then I'm going to mark this top equation because we used that here. Now we're down to this bottom equation where we've got the 2x minus 2y minus z equals 3. And we're trying to get that so that we just have z equals a number. So 2x minus 2y minus z equals 3. The first thing I'm going to work on doing is getting rid of those 2x's. So in order to get rid of 2x's, I need negative 2x's. So I'm going to reuse this middle row in here like we did before, but instead of multiplying by negative 3, I'm going to multiply by negative 2 to help me get rid of that positive 2x. So negative 2 times x is negative 2x. Negative 2 times negative 2y is positive 4y. Negative 2 times z is negative 2z. And negative 2 times 7 is negative 14. Now when we add these two equations together, the 2x and the negative 2x are going to cancel each other out. The negative 2y and the positive 4y give me 2y. Negative z and negative 2z combine to get negative 3z. And then 3 and negative 14 are going to give me negative 11. Now my next step is going to be to get rid of those two y's, but I want to be really careful in here so that I don't reintroduce any x variables. We just went through to cancel out the x's, so we don't want to put any back in there. So here's what I'm going to do. I'm going to look for an equation that doesn't have any x's in it. And in our previous step, we ended up with this equation right here where we had gotten rid of the x's. We can use that equation to help us out. Now I've got two y's right here, so in order to get rid of 2y, I'm going to need a negative 2y. So I'm going to take this new second equation right here, and I'm going to multiply everything by negative 2. So negative 2 times this y gives me negative 2y. Negative 2 times negative 2z gives me plus 4z. And then negative 2 times negative 7 gives me positive 14. So now when we add these together, the 2y and the negative 2y cancel each other out. The negative 3z and the positive 4z give me just 1z. And the negative 11 and 14 give me positive 3. So we get z equals 3. So now this system right here is in row echelon form. So we should be able to use this and back substitution to figure out our missing values. We just figured out that our z value was 3, but we still need to find our y value, and we still need to find our x value. So first we're going to find our y value. Now we know that z is 3, so I'm going to take that 3 and we're going to work our way up. I'm going to plug that 3 in for z in my next equation up. So I get y minus 2 times 3 equals negative 7. Now negative 2 times 3 is negative 6, so y minus 6 equals negative 7. I add the 6 over to the other side, and we should get a y value of negative 1. Then we're going to go up to our top equation, because now we know our y and our z value, and we're going to plug both of those in. So we get x minus 2 times negative 1 plus 3 equals 7. Now negative 2 times negative 1 is positive 2, so we got x plus 2 plus 3 equals 7. 2 plus 3 is 5, and if I subtract that 5 over to the other side, I get an x value of 2. And now we have all three of our values, and we're going to write this out as an ordered triple. So we start with our x value. We just got an x value of 2. We said our y value was negative 1, and we said our z value was 3. Now, like I said earlier, it's really easy to make mistakes as you're going through and doing this process and trying to solve systems of linear equations using this Gaussian elimination. So it's always a good idea to check your answers. And in order to check our answers here with this ordered triple, what we would need to do is in all three of our original equations, the equations that we started with at the very, very beginning, we should plug in the 2 for the x, the negative 1 for the y, and the 3 for the z, to make sure that this does in fact satisfy that equation. But I'm going to leave that part up to you. Now we're going to do another example here, but I'm going to show you what it looks like when we get no solution as an answer. So we're still trying to get this in row echelon form, meaning that stair-step pattern where we're gradually getting rid of variables. My top equation, I want to lead off with a plain x. So if we look at this system that we've got, our top equation already leads off with a plain x. We've already got a 1 in front of that x. So that top equation is fine to use as the top equation in our new system that we're going to build. So I'm just going to transfer that equation over into the top of my new system. But then I'm going to put a mark next to it to let me know that I've used that equation in my new system that we're building. Now we need to work with the negative x plus 2y minus 5z equals 3 equation. And I want to get rid of that negative x. Now to get rid of a negative x, we're going to need a positive x. And this top equation already has a positive x in the front. So we don't even need to do any multiplying. So we can just take that equation as it is and add that together with this equation. Now when we add these together, the negative x and the positive x, those are going to cancel each other out. The 2y and the negative 3y, those are going to give me negative y. The negative 5z plus z is going to give me minus 4z. And the 3 and the 4 should give us 7. Now we want there to be a positive 1 in front of this y, and right now we've got a negative 1. So what I'm going to do is divide everything in here by negative 1. So taking negative y divided by negative 1 gives me a positive y. Negative 4z divided by negative 1 gives me positive 4z. And 7 divided by negative 1 gives me a negative 7. So that's my new second equation in this system. And I'm going to put a mark in front of that equation to show that we've already used it. So now we're down to our last equation here. The 5x minus 13y plus 13z equals 8. And the first thing we want to get rid of are those 5x's. So in order to get rid of 5x's, we need negative 5x's. So I'm going to take this top equation and I'm going to multiply by negative 5. So negative 5 times x gives me that negative 5x that I wanted. Negative 5 times negative 3y gives me positive 15y. Negative 5 times z gives me negative 5z. And negative 5 times 4 gives me negative 20. So we add these together. The 5x and the negative 5x cancel each other out. Negative 13y and positive 15y give me 2y. 13z minus 5z gives me plus 8z. And 8 minus 20 gives me negative 12. Now I want to get rid of those 2y's that are in the front, and in order to do that, we need negative 2y's. So I'm going to use this equation that we ended up with over here, but I'm going to multiply by 2. So 2 times negative y gives me negative 2y. 2 times negative 4z gives me negative 8z. And 2 times 7 gives me 14. Now when we add these together, the 2y and the negative 2y are going to cancel each other out. The 8z and the negative 8z are going to cancel each other out. So everything on the left-hand side canceled out, so we've technically got 0 over there. Now on the right-hand side, negative 12 and 14 are going to give us 2. Now we should notice that something fishy is happening here. 0 cannot equal 2. This is a mathematical statement that doesn't make any sense. So because we're getting this, this is how we know that there's no solution. When you get a statement that doesn't make any mathematical sense, that means that your system has no solution. That's going to be it for this video. Thanks for watching.